You have 50% of the link with 2 letters of 4. I mean, you practically don't bring it.
Leute mal eine Entscheidung treffen können müssen und was ein bisschen von ihrem Legacy weg müssen. Und dass wir nicht einen Plan machen sollen für ein Projekt, was 1,5 Jahre dauert, wo dann sagt, das sind die Milestone.
All right.
Dass wir keinen Vertrag unterschreiben, wir treten den 87 Storypoints und pro Storypoint kriegen wir 100 €. Aber wir kriegen sehr viel alle Spieler ein, die hast du gesagt. Und da ist die andere Sache. Eigentlich auch keiner überspringen will, weil sie auch sehr beschlossen sind.
All right, folks, then let's get started.
Die kann Luca später signieren. Der Autor kommt.
Okay, cool. Then let's have a seat. Yeah. Hello, everyone. Nice that you made it to today's Rust meetup. This time again in hybrid mode, hopefully without sound issues and anything. Let's see. Should be? Oh. Oh. No? Really? All right. First. No? All right. This should be. Yeah. I think it's your phone. All right. So today we thank Mainmatter and Marco for hosting us here, right? That is always nice to find. Yeah. Give it a warm hands of applause. He will also start the first talk about Gerust. Gerust, all right. Sorry, my bad. Yeah, very curious about it. And then we probably will have the food break after the talk. And then after the food, we have Luca and his talk about Pavex and the intro, right? And then time for socializing and so on, right? So yeah, Marco, stage is yours. Yeah. I hand over the mic and getting the party started.
Is that good? Test, test.
I can hear you
now. 1 second, I need to get set up. So we need to switch on the projector. It's not super stable, so I hope it hasn't changed position and we don't need to rearrange everything. So great. So yeah, I want to talk about Gerust today, but let me introduce Let me introduce myself first. So my name is Marco. I'm the founder of Mainmatter. And this is like officially the Mainmatter headquarter, but we're distributed Teams was really my office, but coincidentally, most of the team is there because we're having our Mainmatter day tomorrow. And so this is a rare opportunity to meet a lot of our people, actually. I want to say a few words about Mainmatter, obviously. Right? So we are a software engineering consultancy. We're focused on web and cloud projects, front end and back end. And we help clients to deliver better results more efficiently, more predictably, faster. And we help them adopt new technologies like Rust as well, right? So brief overview of our offering. So we do custom development where clients hand over work that they don't want or they can't do themselves. We are doing training and support. We have an extensive catalog of Rust workshops by now. We do team reinforcement, where our experts join our client's team to help them overcome challenges, for example, around adopting new technologies like Rust. And this often pairs well with training, right? Where we do training first, and then we stay around for a few weeks or a month or so to work with them to sort of help the teams that we trained before sort of internalize the things that they learned in the workshop a bit better. And we give strategic advice, for example, around sort of technical transformation, developer infrastructure processes, and similar. And we have a new thing that is specifically for Rust, which is what we call our Rust support subscription. It's a subscription that gives our clients access to our Rust experts for 4,000 euros a month, right? They get dedicated time with our people. They get access to our Slack to sort of answer questions they run into or sort of get unblocked on something. You can check the details on our website, mainmatter.com/rust. There's a bit more marketing. We don't just do all that consulting stuff, but we also organize a conference, which is called Eurorust. I hope all of you have heard about it or have been there before. We're coming to Paris this October after Vienna last year and a few other cities in the years before. And we do have some stickers over there, some Eurorust stickers, also some Gerust stickers, Mainmatter stickers, and so on. We also, I didn't say that, we also got 30 licenses for Rust Rover from our friends at JetBrains. I think it's just first come, first serve. And we have some of our books over there, and the author himself is also there, Luca, so he can sign them for you later on. Like, again, first come, first serve. Right, and that's the marketing part. So let's switch to content. So you see, overall, we're quite heavily invested in Rust, right? We believe it's great and has a lot of potential that has not yet fully sort of materialized in a lot of areas, right? And one of these areas we think is backend web development. So we think Rust is great for that, and arewebobyet.org agrees Rust is ready for the web, right? All of the different things you need to be covered sort of in order to be able to write web backends are covered in the Rust ecosystem. There's web frameworks like Exam, Actix, there's database drivers, templating, serialization, deserialization, obviously, tracing, and everything you need, right? But in reality, it is still kind of a draw the rest of the owl situation, right? Like, here's two circles, like figure the rest out yourself. In Rust, it's sort of, here's a set of crates, figure the rest out yourself, right? Ideally, though, sort of we will have something on a higher abstraction level, right? So teams can be focused on sort of on figuring out the essential complexity of their projects and not so much the accidental complexity, right? Which is like folder structure, what goes where, how do I set up logging, tracing, how do I organize data layer, which crates do I even choose for the different things, and so on. There are some approaches, obviously, right? So, I mean, the situation has slightly changed also since I first wrote that slide, which I think was like, I don't know, last summer maybe. There's Loco, there's Rocket, and there's obviously Pavex. They are each a bit different in terms of sort of their approach, and we don't necessarily agree with all of the decisions, although I have to say, obviously, we agree with some or a lot of the decisions, all of the decisions that Pavex makes, and Luca is gonna sort of
tell you what those decisions are later on, right? But I think Pavex is also sort of a different approach than what I'm going to show you. Is sort of like a completely new approach, where sort of the starting point being sort of more like, let's rethink everything from scratch and try and come up with a better solution, where the sort of underlying sort of idea for Gerust was more, let's look at the sort of existing agreed upon standard crates for the various things and just answer the question, how do we assemble those sort of for a project, right? For a real project. So that is the idea for Gerust, right? It's our idea of how Rust backend projects using those standard crates in the ecosystem should look. And it's based on mainly XAML and SQLX. We could have used Actix, and there's probably no right or wrong answer. There between the two, there's a lot of opinions, obviously, but I mean, that is often the case. I think what might speak for XAML is maybe sort of it's part of the Tokyo project, which I don't know, makes you feel safer about its long-term sustainability and maintenance, maybe. SQLX is easy to use and it's pretty stable, and we specifically decided against using an object relational mapper because, in particular, for the use cases around web backends that we see, Rust sort of being well suited for, we feel like you would rather have a bit more code, but with lower complexity than have a bit less code or fewer lines of code, right, with an ORM, but then higher accidental complexity overall and a bunch of new concepts that are not necessarily sort of important for your application, right? But I can show that in practice later what that means for us. One important thing is Gerust is not despite the name, actually, because Gerust means framework in German, right? That's the joke. Gerust is not despite the name a framework, right? It's a project generator and sort of project maintenance or sort of development assistant tool in a way, but there's no runtime dependency on Rust, right? Sort of like you create a new project with Gerust, and sort of the project that is created sort of contains all of the code that sort of is needed to run and sort of, or is needed for your application to work. And there's no runtime dependency on Gerust. Like obviously there's runtime dependencies on XAML, SQLX, and so on, right? But sort of you don't have to trust Gerust, right? Which would also be like not a great decision maybe for something that I present here out of the blue, and it's like version 0.0.6 or so. Still, also as a project generator, it sort of answers a bunch of questions sort of that you don't have to worry about then, right? It structures projects into separate crates with sort of separate concerns using workspaces. It establishes a clear folder structure that is sort of is very clear about what kind of thing goes into what file and what directory. Which I think is a very important question, and I think the importance of that question is like easy to I'm missing the word, unterschätzen, underestimate, right? Thanks. And it also comes with generators for sort of creating controllers and entities and so on. While we're not using an ORM, as I mentioned before, we suggest sort of a set of standard patterns for the data layer, which are encoded in the generators again. And Gerust comes with a mechanism for testing and sort of makes sure that every test has its own isolated database, so that you can sort of pre-populate that database with the exact data you need for that test case, right? And it's sort of there's no risk of that interfering with sort of the rest of your tests. So I hope that all sounds good and nice, but words are words, and like we're interested in a demo, I guess, right? Or hopefully. So the idea here is, and I need to switch my arrangement here slightly. Let me just hide a bunch of things. So the idea here is that we're building a note-taking application with a RESTful interface, right? And we're not actually build the node taking. We'll just build the node reading, because otherwise this gets too long. And whoops. So I think that everybody should see my screen in the stream and here, right? Okay. Do I have to make it larger, or is it fine? Or let me maybe, yeah, let me see whether I can, because this is also a bit small for me now. Let me change the resolution. How do I change the resolution? 1 second. This is not, should be here, right? No. Wait. Yeah, okay. Great. So we generate a new application. Is this large enough now? Okay. Okay. So I have installed Gerust, right? Like cargo installed Gerust. There's no precompiled binaries, so because you need sort of a running like Rust environment anyway to work on a Gerust application. Gerust Munich nodes, and that creates the application. And then we can look at this. I'm using the Nova editor, if anyone is wondering. It's pretty limited, but yeah. Yeah, like there's a bunch of problems, but I'm used to it. So right, so you see here's the generate project, right? And it has Docker Compose with like database setup, so you can easily run that. By the way, I'm going to start Docker because we need that. And it's separated into a bunch of crates, as I mentioned before, using a cargo workspace, right? So we have the CLI crate. And I don't want to go into too much detail, just relatively high level. So that has two binaries, CargoDB, that's used for creating the database and migrating the database, seeding the database, and so on. And the other thing is cargo generate. By the way, we have sort of a configuration here, so I can run CargoDB versus like all of this, right? And okay, we'll worry about that when we come to it. So that is used for, like I said, for creating the binary, the database and so on. And then we have generate for creating a bunch of things, the blueprints. Like I said, sort of there's no like runtime dependency on the Gerust crate. It's all part of your application. So the blueprints are part of the application as well, right? There are blueprints for controllers and entity test helper. We won't go into detail, middlewares and so on. You would typically not have to worry about this, but sort of when you have your own generators, sort of that would be the place sort of to add them. Then we have the config crate, which mainly has sort of your config struct here, which like server config means like which port do you want to listen on, database config, obviously like database connection string, and so on. Right, and then sort of it can sort of like pass the config from like a set of configuration files and environment variables and so on. Macros, that is Cargo's own test macro, which implements the mechanism for setting up test-specific databases for each test and tearing them down again once the test is complete. As I mentioned before. And then the really interesting stuff is in the DB crate, which contains migrations, obviously, right? But also entities, which is sort of what in Rails and many other frameworks would call models, right? Sort of the structs essentially that represent the data that your application cares about, and then web is the web interface, right? So the web interface has like controllers, middlewares, like routes and application state and so on. And so typically, sort of for a RESTful interface like the one that we are building now, sort of you will have nodes controller with a nodes endpoint for reading the nodes, and the nodes controller will use the nodes entity and related functionality from the DB crate to read the nodes from the database and then sort of convert them to JSON and so on. So what we can do now is we can start with creating an entity, because for a node-taking application, we need a node entity, obviously, right? And we can run cargo generate entity node. Sorry, it's not Gerust, it's cargo. And I don't know what's up here. I'm not sure what doesn't build when I run the generate binary. Okay, so that works. And by the way, like we just generated the project and we can already run it, but obviously it doesn't do anything. There's no endpoints yet. So let's go back to. What? Edition 2024. You need to update your Rust. Rust 2? Rust 2 shit, I should have tried it. What's it? Rust up? Something like this? Okay. Yeah, but the dependency requires edition 24, right? Yeah, I mean, you can obviously also just adjust the edition to 2021. Yeah, but I mean, if the dependency requires the edition, then I would also have to downgrade the dependency and so on, right? All the version of dependency. I mean, what is Cruet? I don't remember. Let's look at what Cruet is to pass the time. Oh yeah, right. That is inflections, right? So you can sort of like pluralize, singularize, camel case, and so on. Because when I do something like cargo generate entity node, then we want to create a file that's called nodes.rs, but the entity needs to be node singular, uppercase, and so on, right? So we do a bunch of things with a string you're passing. I mean, this is roughly inspired by Rails, but I would say the framework as such is not inspired by Rails. There's a bunch of things sort of that we take from Rails, but also there's a bunch of things that we don't want to take from Rails. Because, I mean, for example, the sort of Rails default scaffolding, right? Sort of where you have sort of, essentially you have like relatively tight coupling from sort of the database to the view layer, because it's made to be all the same, right? We don't necessarily want to replicate that in Gerust. But we want to, still we want to replicate sort of the simplicity that Rails offers as much as we can, right? Without sort of giving up separation of concerns and so on, right? So I mean, one example for that is, for example, to not use an ORM, because it's magic. It's sort of the ORM stuff, the ORM types in particular in a language like Rust, obviously, leak into sort of all of your application, right? Versus when you're just using sort of like bare Rust structs, sort of, you don't have any additional concepts sort of that leak into your application, right? Sort of additional stuff that is sort of like encoded in the entities that you use everywhere. But you have a bit more code, but maybe that's fine, right? So I think in general you would probably not use Rust for sort of the same use cases you would use Rails for, right? I think like I would use, or I recommend Rust to clients for backends when they want to build something where they care a lot about stability. Like Rails obviously is typically not super stable, right? So if you get to a result fast, but then sort of actually making that sort of production ready and stabilizing it is a bunch of work, right? Like with Rust, it's maybe the other way around, right? It takes you a bit longer maybe to get to something which you're trying to address with Gerust, right? And make it a bit easier, but still sort of there's a bigger sort of initial step, but then what you get is much more stable, right? It's easier to maintain, and a bunch of other things. Sort of I think for those use cases, sort of you don't necessarily worry too much about the lines of code that you have, right? If the lines of code that you have are like relatively simple and easy to maintain, I think that's better than, as I said before, having fewer lines, but a lot of magic stuff sort of going on, which sort of makes it much harder to reason about the application, really. Right, so hopefully this works now. So we generate an entity, and I forgot we need a field as well, right? So we are saying we create a node entity, and that has a property text of type string. Fingers crossed. Yeah, it's probably going to be fine. Right. So now we have in our database, in our DB crate and entities, we have nodes, right? And node is, like I said, just a struct, right? With an ID field. By default, sort of we're using UIDs, and we're always creating the ID property because it's likely you want to have an ID, right? And then sort of we have the text field of type string. We also generate a change set, sort of from here on, essentially, sort of from line 15 on. So this is where sort of the stuff that Gerust has instead of an ORM starts, right? So the first thing that we create is a change set, right? And sorry, can I make that go away? Let's. I don't like this file panel on the left, and I can't figure out how to put it on the right instead. So that's the main reason really why I use Nova. So we generate a change set here, right? And the idea of change sets is actually sort of like taken from or inspired by the Ecto library in Elixir, right? Which also has change set. And sort of the idea is when you create a new entity, you create a change set, and then you pass that to a function. If it validates, if it sort of is like successfully applied to the data store, then you create the then you receive the entity in return, right? And the same for updates, right? You have an entity, you create change set sort of with the updated properties, right? You apply that, and then sort of you get an updated entity in return, right? And this is essentially what we're doing here, right? So if we have a change set that does not have the ID field because you're not supposed to change that, right? There's a database thing to assign that when sort of the node is first created, but you will be able to change the text property, and you want to have a validation here, right? Here we can say, I Oh, right. Yeah. Whoops. We want this, right? Because why not? And we also set up we also set this up for fake data, so I can create fake data for my tests easily, right? In this case, yeah, I think we can do sentence, right? This means I can create a sentence between 1 and 10 words, and then later in the test, I can go no change, or I can say no change fake, right? And sort of I didn't have to do anything to make them work, obviously. Right, then we have like all of the data access and data manipulation functions, right? Instead of an ORM, we just have a bunch of functions. First one is load all, which is sort of, this is like not something that you would typically actually use in an application, right? Unless if you know you're never going to have more than like a small number of records. Sort of this really should have some sort of paging, but that loads all of the loads. Then of the nodes, then loads one node, creates a node based on the change set, as I said, right? It validates the change set. If that is successful, applies the change set to the database, and then and then responds with an entity, right? And update is the same thing, essentially. You pass a change set, apply it if it's valid, and then sort of you get a node entity in response, or of course no record found might happen as well, and same for delete, essentially, right? So here you see this is red because we're using SQLX, which does sort of like development time statement validation. I'm not sure what term they are using. So that doesn't work because we don't have a nodes database yet, right? So we don't have a nodes table yet. And I'm just quickly gonna start up the database. So as I showed before, comes ready with a Docker Compose setup with databases like one for development, one for testing. Yeah, this should be fast. And then we can generate a migration, say create nodes. That should work just fine. So you just like timestamped migrations, and like so you have ordering built in. I'm going to copy the create table. So from and this is, by the way, the tutorial on Gerust RS, right? Which is essentially a longer version of what I'm showing you. So we can put.
It doesn't generate SQL yet.
No, it doesn't. No. So it's not like Rails in that regard, so that it would generate everything for you, right? It generates a bunch of things, but like I said, we don't want to have that sort of strong coupling throughout the entire application. We could generate some more things. We could probably generate sort of a migration without giving that up, but this is 0.0.6, I think. So it's not really full featured, but it's also, like I said, there's no dependency really, right? This is all your code anyway, so you could still use it and get started, and then sort of like you still benefit from it because you still don't have to do the things that Gerust does for you already, which otherwise you would have had to do yourself. Yeah.
How would you update this if there's like extra features coming out?
We don't know yet. It's going to be hard, probably. Maybe we can build something that makes it easier, but TBD.
I guess you have to like parse the code, check which functions are there, which ones changed, and then probably prompt the user with
Yeah.
key.
I mean, that's the thing. It gets very, very complex, very, very fast, right? So maybe the answer is just create a new project with a newer version and look at what's different. And I mean, maybe that's a good enough answer, right? So yeah, but yeah, fair point for sure. Like, good question. So now we have the migration. We put in the SQL that we need. We have the database running, so now we can go ahead and create the database. Okay, I probably did that before, so we can migrate the database. No, I didn't do it before, but the database is automatically created because we have configured Docker that way. So now we have created the database. Then this should mean that these red lines should go away. Error communicating with database. Okay. Let's ignore that for now. But we should be able to run this now. Yeah, right. So that means everything is fine, right? But of course, it doesn't do anything because we only created the entity and the migration. So next step is to actually add a controller, right? And add an endpoint. So cargo generate, and we can generate a CRUD controller, which comes with all of the CRUD, like create, read, update, delete endpoints already. So that saves us a bunch of work.
You have different controllers than other than CRUD?
I mean, yeah, there's also just controller, which essentially just creates a more or less empty file. Right. So we have the controller. It says do not forget to route the controller's actions in web source routes, because we're also not doing that automatically because it gets arbitrarily complex, right? You have made your own changes to the routes file. We need to sort of route the newly created controller sort of in a non-destructive way. I don't know, maybe keeping the formatting, or maybe the file is currently invalid Rust because you have some changes. Like, shall we write into that? Right? Who can say that? So obviously that's easy on Rails, right? Because sort of you have all of this sort of inflection stuff essentially, right? Which is sort of like simple things at runtime dynamically, right? Which we can't really do here. So anyway, we have the controller. This comes with all of the functions, right? So I'm gonna delete a bunch of stuff here. So there's an example code in all of those, and like to-dos, right? Telling you, okay, like put this stuff here, sort of change this code according to your needs. But we only care about read all here, right? Because I think have been speaking for quite some time already, and we don't want to. I don't want to listen to me forever. So what this does is sort of, it has sort of debug configured. We add this here as well. But what it does really, it sort of, it uses the nodes module, the load all function, right? Sort of database pool is coming from the app state, which is also sort of set up automatically when you generate the project. So it's here sort of in like state.rs. Sort of we have the DB pool, which sort of connects a pool based on the database configuration coming from the config crate, and we have a .env file here that sort of contains the configuration that we need, and so on. So this is all sort of the exponential complexity that I mentioned before, right? That you would not necessarily want to deal with, because it easily takes you whatever days or weeks or so, depending on your proficiency with Rust, I guess. Okay, so what this does here, it reads all of the nodes, and we're responding with the nodes JSONified, right? Which is exactly what we need. We need to route this, and we need to, let me remember, this is get, right? No, and then we use create controllers, not greet, but controllers nodes, and then this is and then route get nodes read all. All right, so if no, what's wrong? Right, yeah. So and so no. Yeah, this is the problem with live coding. Okay, but now it should probably work. No. Is it maybe routing get, right? Yeah. Okay, and then we can call. So let's. Right. So no nodes. I'm quickly gonna insert. I know we can also. Let's do one thing, because then I can show you one more thing relatively fast. We also have seeds file, which is typically so for like more or less static seed data, right? Like currencies, countries, languages, and so on. But we are just gonna misuse this for creating a node text hello, and then cargo db seed should work. Yeah. So right, and I think that's it. I could show how to write a test, but maybe I'm just going to show the generated test real quick. Sorry, that's here. And we're not going to make that work for now. So let's look at right here. We have a test read all, right? We're using db test. That's Gerust's own macro, and that means we're getting this context passed, and the context allows us to access this test's specific database, right? That's sort of a copy of the main test database that is sort of has a random name essentially, right? That is like automatically generated for the test. And we use that sort of to create a change set for a new node using this fake data mechanism, right? We pass that to the create function that we saw before. And then we know when we read all of the nodes from the database, we get like exactly that one node, right? And then we can have a very specific assertion on the response, right? And that's essentially how tests work. But yeah, it might take a bit of time now to get this working. And now I'm going to switch back to the presentation real quick. I just have 1-2 slides, I think, that I want to show. And I hope that everybody here and in the stream sees everything. Good. Yeah, so that was the demo really quickly, or not as quick as I planned, showing how Gerust works, right? What sort of the basic sort of like building blocks and so on. We have a bunch more stuff built in, like it's set up for tracing. We have support for transactions. We have support for middlewares and so on. So this is sort of more or less ready to go live, right? And sort of are not doing a bunch of things using this that you would have to do yourself when sort of assembling a set of crates yourself. But there's plans for more. So there's a bunch of things that we don't have. We don't really have a deployment story yet, where you can just sort of, there's something in the README that says to deploy this to production step 1, 2, 3, right? It might not need a lot of code, but I think there's a lot of value in just having something in there, right? Saying like, we recommend this way of deploying, and like I said, step 1, 2, 3, right? Your life. We need to complete the data access layer. There's a bunch of missing things. Like I said, the read all function should not actually be something that anyone should be using, right? You want to have some sort of paging built in. Probably if that can come out of the box, that would be good. There's no concept of relationships between models yet, right? And that gets a bit complex maybe also without an ORM, but there's probably sort of a way that we could recommend or that we could suggest sort of for implementing relationships. And there's no background jobs thing, right? And I think in any real life application, you at some point that is not sort of too far after starting with the application, you will need some sort of background job mechanism. And I think Gerust could have some sort of like suggested or recommended setup, whatever Redis, and then your workers code goes here, whatever, and this is how you run this. And then later, there's a bunch of other things that I think might be interesting. Currently, it just works with Postgres, which I think is awesome and is probably good for 90% of the use case, but I don't know, maybe SQLite or MySQL, whatever, might make sense as well. Maybe some sort of like modern database would also be interesting. Open API integration would be interesting, and automatic upgrades, or at least a documented way or that sort of helps you make that like probably relatively hard and annoying manual work easier. Yeah, but I mean, this is essentially ready to use, right? Sort of, it's just a generator anyway. So if it gets you from sort of step 0 to step 3, might get you to step 7 and 17 later on, but step 3 is already better than 0. So we invite you to use it, give us feedback, and yeah, that's it. Thanks.
Anyone, any question? I have one.
Yeah.
I had a look at the code and see that you are using cargo generate heavily under the hood.
Yeah, which you contribute to, right? Or
yeah.
You're the main method. Okay. Yeah.
And yeah, so it bothered me also that, you know, mixing Rust code with this liquid syntax is kind of pain in the ass, right? So the IDE doesn't support it, right? And it's super horrible actually. How's your, I mean, since you're using this extensively, how do you deal with it? Are you like always generating it locally using these cargo generate testing options, which automatically does the testing in the background generating so that you can have a watch job on it, or how you?
I did not even know about that. No, I mean, I'm just I mean, I wrote this while learning Rust essentially and learning to build backends in Rust, right? So essentially what I did is I wrote, I think the first thing that I wrote was actually like a note-taking application or so, like a simple use case, right? And sort of answer and sort of like to run into all of these questions that we're answering in Gerust, and then find the answer and sort of like codifying that into Gerust. So what I did, sort of, I wrote the application first, and then sort of like converted it to a blueprint. And sort of, I think the approach for that was really just like regenerate until it works, fixing liquid errors and fixing. I mean, also we want like we want cargo format to sort of not report any formatting violations, sort of, for freshly generated projects. So that meant figuring out a bunch of new line things with liquid, which was very annoying because you're like you're generating something, it works, but there's like one new line too much somewhere, and then you have to figure out, is it like minus there, and then sort of you have no new lines, and it's annoying, but I mean, that was not really the hard part here. So once you know what to generate, it's kind of easy enough to write sort of blueprints or templates that result in the code you want.
But the thing is, I'm wondering about the maintainability, right? Because as you said, right, you have first codified it, and then you transferred this code, this working application, into a template, right?
Yeah.
And then you have to keep it alive somehow, right?
Yeah.
And if, for instance, SQLX has major changes in the API, you probably have to touch a couple of places then. Either you do this in your main application and retransfer to templates, or you do it in the templates, and then you lose all the nice, code auto-completion tooling and stuff like this. And
Yeah.
it can be pretty annoying, pretty hard to sustain over time. Right?
Yeah, for sure. I mean, we do have relatively extensive CI setup. So essentially, this is probably too small, right? Essentially, what we do is sort of we run the test for Gerust itself and so on, and then we just like generate a bunch of applications. So we have different blueprints. You can have a minimal application that doesn't have a database, full application. We have a full example application that has sort of a full CRUD implementation for, I think, tasks and a middleware and so on. So we generate all of these applications and then run them, right? And make sure they work, right? Which is, I mean, it's smoke test, right? But you would typically sort of, we should find that anything that goes wrong in terms of like major dependency updates or like mistakes and in the current generate templates, so that like all of that will result in some of these things go red. And that seems good enough. Cool. Thanks. I guess we have like a break, no?
Some lightning talks?
No, I think the lightning talks are cancelled.
Yeah, lightning talks are gone. Yeah, a second. All right, so lightning talks are cancelled. They're gone. Sorry about that. There was a misunderstanding. No worries. So I think now we can like start the food break. If there's food yet, nice. If not, then we just have a drink and wait a little bit. And then I think next talk will be from Luca, and maybe in half an hour or something like this. And then, yeah, we wrap it up. Okay? All right. Thanks. Now I think there's the green light.
Nice. So Sven said yes, which means we can start. First of all, thanks for staying after the food. That doesn't always happen. It's much appreciated. You may have noticed a different talk title on the schedule. That's because I was supposed to do something else, then realized I only had 30 minutes, so kind of brought another talk in the meantime. So tonight we'll be talking about dependency injection. We'll be doing a review of the state of the art. So it's just generally what dependency injection is, how people do dependency injection in Rust, how does that work, why it's good, why it sucks, and why Pavex does it slightly differently. So that's the theme of the night. Before we get into the nitty-gritty, a little bit of an introduction. My name is Luca Palmieri, and I work here at Mainmatter, as in the company, not here in the Munich office, as their principal engineering consultant. And I look specifically after the Rust side of the business. So training, strategic consulting, staff augmentation, all that stuff. Ooh, our audio is coming back to me. Let's mute this computer. Beautiful. You can find myself on the internet, mostly on my website, where I used to publish more articles, as that's the tale of every blog that people keep. I've been in the Rust community for several years at this point, wrote articles, maintain a bunch of tools, maintain a bunch of libraries. I am probably best known as the author of Zero to Production in Rust, which is a book that introduces people to backend development with Rust. Uses an hands-on approach, which is the same type of methodology that we use for this, which you found down there, which is an introduction to the Rust language in 100 exercises. Every exercise has a bunch of theory and then tries to verify your understanding. Cool. Enough. Let's get into the meat of the talk. Dependency injection. Before we go into how people do dependency injection, it's probably good to establish why we may want or not want dependency injection. For every framework under the sun, you'll find always the same promise. We'll let you spend more time working on your business logic. That's pretty much every framework. Like you can substitute your favorite language, your favorite framework. They all make the same promise, which we can convert into the negative. We try to minimize the share of time that you spend working on glue, so trying to stick together different things that may have not been designed to be stick together, or the time that you spend doing business agnostic code. Classical example might be you have an application. This application needs a dashboard. This dashboard needs authentication. You need to write an OAuth2 social login. That's going to be the same 99.9% of the time for every single application. If you're writing it from scratch every time, you're wasting time. You want to write it once and reuse it. Even best, you want someone else to write it for you. So you want to delegate these business agnostic tasks either to the framework itself, if it comes with batteries, or to the ecosystem around the framework, if they provide the batteries. Hopefully, they kind of fit together. Nice. But you can't just delegate the whole request processing pipeline because your business logic is going to be in there. So you need to find a way to decompose this complex request processing pipeline into smaller units. And then we're going to write some of those smaller units, and we're going to outsource the other half that we don't care about. Now, dependency injection is one of the ways in which you can do this decomposition and recomposition. It's not the only way. You can simply say function calls are perfect for composing and decomposing and go down that path. Notably, in the Rust ecosystem, that's the choice at Dropshot, as one of the web framework does. No middlewares, no dependency injection, just write functions like the good old days. And that's fine. Like for some applications, that's perfect. But other applications try to make it so that you can break these small units out and you can compose them in a way that's a bit more nice. At a high level, when we think of a request handler, we can modulate as a function of the incoming request, so whatever's coming on the wire, as well as some kind of long-lived state. That state may live in a database, may live on disk, may live in memory. We are going to access it to know how to process the request, and we may also mutate it depending on what we're trying to do. The outcome for the caller of our API is going to be a response, so some kind of HTTP response that goes on the wire. Let's look at a fictional request handler. You may have a request that's coming in, you have your application state. To process that request, you may need to do some downstream HTTP calls. So you've got a provision HTTP client. Now, since you want to be able to debug it, you also might need some diagnostics. So you'll need a logger. Then you'll want to authenticate. So you'll need to extract the user ID. You'll have to check if it has enough permissions, for example, to do what they're trying to do. Then you do the actual thing that you want to do. And in the end, whatever is the outcome of that operation, you got to marshal back into an HTTP response. Now, we might want to say that all those subunits can be moved out of the handler. So we might want to have a handler that actually looks like this. Don't make me build the HTTP client in there. Don't make me build the logger in there. Don't make me extract the user ID. Just give them to me already done. I'm going to do the permission check, the business logic, and then convert back into the response. It goes smaller, like the share of business logic over the total number of lines in that function just go higher. And if you wanted to, you could take this farther. We'll see how. But generally speaking, the pattern here is that to allow that kind of signature, the framework now must have a way to look at your handler and say, what needs to be built? So what are the dependencies of this handler? And once I've identified them, how do I build them? So how do I get a logger? How do I get an HTTP client? How do I get a user ID? And the way that you usually do this, either explicitly or implicitly, it's not necessarily going through this graph step, but you look at the handler and you say, what are the inputs? A, B, C. Now, how do I build B? I need to call this function. This function itself is going to have inputs. I'm going to take them, etc., etc. This looks very simple because it's a toy handler. Reality is much more massive. It's going to have tons of nodes, tons of edges. It's not going to fit nicely into a slide. But it gives you the idea of the type of reasoning that a framework that supports dependency injection needs to be able to do. Cool. As I was saying before, we could go one step further. So we could take those preconditions that is authenticated and make it a precondition to the invocation of the handler. We could also take the marshalling out of the request handler. So we could get to something that looks like this. Handler, these are my inputs, only gets invoked if the user is authenticated. I do my business logic, I return the outcome directly. Somehow that's going to get converted into a HTTP response. This may start to feel kind of familiar if you've been doing some web dev. It's what you usually try to write in mature frameworks, so to say. Now, that's where middlewares were coming to the equation, but we only have 30 minutes, so we're not going to talk about that. What does, so we have established what dependency injection is, we have established why you may want it, and we have established what job the framework needs to make it happen. So the question now becomes, what does a great dependency injection system looks like? And here comes Luca's specific opinions. Number one, it would be ideal if when you're trying to do this dependency resolution, all mistakes, all missing dependencies, all dependencies that you don't know how to build, or circular relationships, they should be code at compile time. I don't want my users to ever, try to hit an endpoint and get a 500 back that actually under the hood is a failure to resolve one of the dependencies. And secondly, kind of bonus points, it'd be nice if the error is easy to understand. You get cookies for that. Two, we want to outsource these units to someone else. So we don't want to build that logging. We don't want to build that JSON deserialization. We don't want to build a lot of things. But we also need to compose them together into something that makes sense as a cohesive unit. To make a very specific example, if you have an API which you're offering as a service to a client, that API is going to have a schema. For example, it might be very specific as to the way errors need to be communicated back to the caller. All the errors, for example, might need to be JSON objects, which have certain fields, and those fields have to be defined. Now, if you have extractors, as we've seen before, so creating an HTTP client or trying to extract the user ID, if those fail, those errors will have to be marshaled. And we want those to be marshaled according to the schema of our product, which may or may not be the schema that whoever wrote that, crate on crates.io is using to serialize those errors. So we need to be able to tune these units a little bit so that what comes out at the end as a cohesive whole actually makes sense. So that's requirement number two. Let's review what's available. What do we have? Number one, first thing to...
We just lost the screen share, I don't know.
Oh, technical problems. Yes, we have lost the screen share. Let's recover it. Consent. Screen. My browser blocked the screen. That's very ominous. Let's change browser. Oh. Spoilers. Don't look. Yes. Condividi. Sì, nice. Oof.
It's quite a journey.
Is it not? Cool. Are we good?
Yes.
Nice. Well, what happened there? Okay, where was I? Well, we stopped me just at the beginning of the second section, so it's good. So first thing to take notice of, most frameworks, most of the most popular Rust frameworks actually have dependency injection. Axiom, ActixWeb, Poem, like the list goes on and on. These all have a kind of dependency injection system. And all these dependency injection systems are trait-based. So they work around the concept of a trait in Rust, and we'll see what that means in a second. So let's look Axiom as a reference. I'm not picking Axiom for any specific reason beyond the fact that most of you may be familiar with what that looks like. But statement is exactly the same in every other frameworks. The traits may be named different, and the types may be named different, but the system is identical. So if you want to inject something into an Axiom handler, you need to implement a trait. There's two different traits, one for stuff that looks at the body and one for stuff that looks at the head. That doesn't matter too much. It's just borrow checker details. The trait to extract from the head looks somewhat like this. I've amended a bunch of sensing things around just to make this fit nice. So you have from request parts. You're taking as input the parts of the request that's coming in. That's the version, the method, the header. That's pretty much it. You're taking the application state, so that long-lived state that you may need to refer to fetch some stuff from. As a result, you're returning self, so the implementer of this trait, the type that you want to make injectable. This extraction may fail, so you may return a rejection type, which is an associated type. The only thing that we want from the rejection is that it needs to implement into response. So if I fail to extract, that means I need to stop the pipeline, return the error to the user. To return the error to the user, I need to send something over the HTTP protocol, so it needs to be convertible into an HTTP response. Pretty simple once you remove all the trait bounds. Now, the framework relies on the Rust compiler for two things. A, to ensure that all your inputs, so all your request handler input parameters, do implement these traits. If that's not the case, the framework would reject the handler. And two, to actually resolve that method and invoke that logic. So if you're writing, this is like straight from the Axiom documentation. If we're writing a create user handler that needs to deserialize some JSON payload, which is here, if JSON didn't implement the trait from request, this registration down here would fail. So the compiler would say, this doesn't implement terrible things. You can register it as a request handler. So that satisfies the failure compile time requirement that we were discussing before. Said that, the way this works is actually extremely fascinating because you need to be able to inject variable numbers of inputs, right? But Rust doesn't have variadics, which makes this incredibly tricky. There's a very good talk from Rob Eade, which is the maintainer of ActixWeb, which uses, as I said before, exactly the same system as to how you get traits to do this thing for you. It involves a lot of tuples. That's a spoiler. I'm not going to go in there. It would take 40 minutes, but I do recommend you checking this out if you just want to understand how Axiom or ActixWeb do this. Said that, let's evaluate it from a user perspective. Like, we don't care about how it's implemented. Let's look at how it works. Number one, this is a big pro. The Rust compiler is all you need. There's no additional tooling. You run cargo build, dependency injection, either works or doesn't work. Number two, to learn how to use this dependency injection system, you need to learn how traits work. But that's a positive, because traits are a foundational concept in Rust. If you're doing Rust, even semi-seriously, you will have to learn how traits work. So learning to use the framework forces you to learn a concept that you'll be able to reuse elsewhere. That's a very nice learning journey. So that's nice. Obviously, there are some downsides. Otherwise, this talk would be a very short one. And the first one is that composition errors are not always caught at compile time. And let's see what that means. As I was anticipating at the beginning, dependency graphs in the wild are much wider, but most importantly, are much deeper. What that means is that a unit depends on another unit, which depends on another unit, which can be summarized as dependencies have their own dependencies, recursively. Now, if we go back to the definition of the trait, which is right here, this allows you in the request handler to inject a bunch of types. But you can't inject anything. You cannot inject anything here. And that's because if you try to implement a trait, the trait implementation must match exactly the trait definition. If to extract, let's say, the user ID, you need to have access to the session state, there's no way for you to take the session state here as an input, because that would violate the contract of the trait. Now, obviously, so trait method can accommodate recursive dependencies. Obviously, there is a solution. Otherwise, these frameworks wouldn't have dependency injection. And the solution, the workaround, really, not a solution, is to use a type map. If we can't get things through the signature, we snuggle them back somewhere else. So every framework in Rust that has dependency injection that works with traits at its deep, darkest core as a type map. A type map is a hash map that is keyed by the type ID. For those of you who haven't spent a lot of time in that part of the standard library, first of all, you're very lucky. Secondly, type ID is an opaque identifier that the Rust compiler generates for any type that implements the any trait, which basically means that it doesn't have lifetimes if you really squeeze it. So a type ID is something you can ask the compiler to give you by just giving it a generic parameter with that type, or just by giving it a value. And it'll tell you type ID is a string. There's no structure to it. It's just a random identifier. There's a bit of structure, but you're not supposed to rely on it. So when you do an hash map of type ID box D in any, what you're basically saying is, I have a bunch of values of various types, and I just want to put them all in one place. And I want to be able to say, store a value with this type, and give me back a value with this other type. So you're completely losing any kind of type system structure that is deductible at compile time. Everything becomes runtime verified. So that allows you to do this thing with different types, but obviously has some cons. Before, all the relationships were actually tracked through the type system. Now, instead, rather than asking for things as parameters, the upstream nodes are inserting into the type map, and then downstream nodes query the type map at runtime to retrieve the values that they need. Going back to that session example, if you need the session state to extract the user ID, what that means is that in your extractor, you're going to get parts.extensions.get session. Now, if you were careful to actually register a middleware or a component upstream that creates the session, that works. If you forgot, that fails. Now, it's easy to find out in a small application, can be surprisingly tricky to debug in a larger application. So that's not nice. Because fundamentally, we have taken an explicit relationship, one that was clearly visible in like input parameters, and we've turned it into an implicit dependency that depends on the ordering which components have been registered. The best. Now, I will settle that, so let's skip. Let's get to the second requirement, and which is the second downside. Customizing a unit when you're using trait-based dependency injection is actually surprisingly non-trivial. And that is because the trait system in Rust tries really hard not to let you do this. The whole trait system in Rust is designed to prevent ambiguity. What that means is that the compiler, for a given pair of trait and type, allows you to have either no implementation or one implementation. There can never be two. That's why you have the orphan rule. So that's why the compiler doesn't let you implement a trait defined somewhere else for a type defined somewhere else. Because if more than one person does this, then there's multiple implementations. Which one do I call? I don't know, so I will disallow that. What this means in the I terms, so if we look at the dependency injection kind of outcome, is that for the I systems that are based on traits, for a given type, there can only be one recipe. There's only one way for the framework to instantiate that type. And that's because there can only be one implementation of the trait that the framework uses to inject the type. Now, let's look at an example, JSON, just because it's a very common one. The JSON inside of Axiom implements the from request trait, so the variant that uses the body instead of the head. This is the implementation. Now, as you can see, there's a certain rejection type, and there's a certain function body. Now, if I want to change the way JSON is deserialized in any way, so for example, I want to take away SERDY JSON, and I want to use eSERDY to do deserialization, or I want to use a CIMD JSON deserializer, I need to create a new type. I can't change the trait body in there. That's not allowed. If you want to change the way the error is reported, for example, so if we go back to the definition, rejection here uses JSON rejection. JSON rejection will be converted into a plain string response. So you're asking your user for JSON, and if the extraction fails, you're sending back just text, no JSON. That's generally not what you want to do. So most applications in production can't use this as is, because that wouldn't fit the schema of a JSON API. Like you get JSON in, you send JSON out when it fails and when it succeeds. But you can't change JSON rejection. So what you need to do is you need to create a new type, call it myJSON, change the rejection type to be one rejection type that you control, implement into response for your new myCustom rejection, and then you're off to something. But the problem is that you're not done. Like you now need to make sure that everywhere in your code base, you're using your own custom extractor. Otherwise, bad errors slip through. And it gets worse than that because you also need to make sure your dependency tree is using your new extractor. So say, for example, you are importing an OAuth2 authentication flow, which defines a bunch of routes. That those routes needs to marshal JSON. They're going to use the Axiom default extractor, which means they're going to have the error you don't want. You want to fix that, you fork it. Not the best. So yeah, it's really non-trivial. Oof, that was a long run. Which brings us back to Pavex and some water. Lovely. So Pavex is a framework for building Rust APIs. It's a personal project of mine that's been going on for a couple of years. If you never heard about it, that's good. It's because it was in closed beta. It's still in beta, but now the beta is open. So if you want to try it out, you can. It's on pavex.dev. And Pavex does provide dependency injection, hence this talk, but we don't do it with traits. So we do it with a slightly different system, and we're going to look into that. And that's the time when I see it, which is good. Feels really good. So is this big enough? Yeah? Could be bigger? Okay, cool. Oh, what did I do? Okay, nice. So Pavex, has many frameworks, comes with a CLI. This CLI can do things. Most importantly, it can scaffold new projects. Like the best cooking shows, I scaffolded a project beforehand and compiled it so that this is going to be fast. So you're not going to see that part. It's quite simple. I am going to start it up here. I think I had a command in my, yes, shell history. So throughout this demo, I'm going to have a cargo watch in the background that kind of recompiles the project and relaunches it every time so that hopefully you don't see too many like waiting for compilation steps. As you can see, the API emits logs in JSON format, which is quite nice. And it's going to tell us that it's running on 8,000. So just to check, we are off to a great start. Well, there's a lot of things. Just gonna ping it, returns us at 200. The logs also confirm us that we got the response. So this demo works. It's not doing anything interesting, but it works. Oh, that is small. Big, big, big. So Pavex, just like Gerust before, provides you with a bunch of things. That's hierarchical configuration, telemetry, beautiful stuff. We don't have time to discuss any of that tonight. So we'll go straight to the way dependency injection works. Pavex, like Axiom in a way, as kind of a single struct that you define things against, which is the blueprint. You define routes, you define middlewares, you define constructors, as we'll see before, and a bunch of other things. So let's create a new route. We'll call it greet, and we'll be at self greet get. Ooh. Beautiful. And then I'm going to create a module for it. It's not the best. Oh, the most ergonomic code writing experience, but I'll do it though. Nice. So we may start with something. No, I really don't want your code completion, friend. Get. Nice. Let's start with something simple. This is going to return OK. And we are missing an import. Cool. This should be recompiling, which is good. And then we are just going to check again that it works. Nice. So we get 200. So what do we want to do? I'm going to write a handler that looks somewhat like the one I showed you in the slides. So it's going to do some pre-computation, and then we're going to step-by-step extract those out, and we'll see what that looks like. We're going to do something very simple, and you really shouldn't be doing in your own applications. So we're going to use it. We're going to authorize people by checking the authorization header against an hard-coded string that's going to live in the code. Don't do this at home, disclaimer. Pavex allows you to inject things into the signature. There's some types that we call framework primitives that you can always inject because they are part of the request response pipeline, namely the request. You can always get that. Just like Axiom, we distinguish between the request head and the request body. The head is the one that has the headers. Since we want to do... OK, that's a very valid complaint. No, it's fine, it's fine. I can go... So you are the one person that always needs to exist into an audience, because you'll show up there with font size 9, and you're like, can you all see down there? Yeah, sure. Nobody can see shit, but nobody will say anything. So I will appreciate you tonight. What are we saying? Yes. So we get the request head. This will always work. From here, we can get the headers, and then we can get the authorization header. Nice and simple.
We lost the screen share. Sorry.
It's really painful. I don't know why this happens. Are we good?
Yes.
Nice. What was I doing? Yes. So we are extracting the... Are we fine? Okay. Okay, cool. While you were talking, I kept writing code. So what are we doing? We have the head, we're getting the header, we're checking for the authorization header. If we have it, we extract it. If we don't have it, we return an authorized response. And then we're going to do this awful thing when we say, if the header is not equal to a magical value, then we're going to say that you are forbidden. If you're not forbidden, then we'll just say hello world. Cool. So not something I would do for work, but I'll do for tonight. In the meantime, Cargo watched this job, so things recompiled in the back. Let's check that it works. So if we send a request to greet and we don't specify an authorization header, we're getting an unauthorized, so that is good. If we specify an authorization header which doesn't have the magic value, we get a forbidden, which is good. And if we specify, let me in, we get a 200 OK. So authorization is basic, but it does what it was supposed to do. Lovely. So imagine that you're doing this for 20 request handlers. You don't want to write it in each request handler every time, because it'll be a pain to manage it. So the thing we want to do is we want to move, first and foremost, that authorization extraction outside. So we're going to define an authorization struct. Will contain another value. I'm going to show off taking a reference here, just because I can. And then we are going to say, I want to take an authorization here. Nice. And if the authorization .0 is different from letting in, then return something bad. Now, as we stand right now, this should not work, right? Like, I defined a struct which contains another value. There's no way for the framework to know how to figure out how to build me an authorization. So good framework here tells you, slap on the hand, this is not OK. And we built a good framework, apparently. So the framework tells us a compile time, very important. And this error is coming from Pavex. It's not coming from the Rust compiler, even though it may look similar. I can't find a constructor for your thingy. Like, you want an authorization. You want it as one of the inputs for get. You register that route here, and the input that you want is this. I have no idea how to build it. So if you want me to fix this for you, you either need to give me a constructor or do a bunch of other things, like take it from configuration, other options that Pavex provides. But let's take the first suggestion. Now, there's extensive docs that explain to you what register a constructor is. In a beautiful next version, they will be linked directly in the header, but we're not quite there tonight. So let's do it. Let's first and foremost define the function that actually is going to do the extraction. We're going to do it with a nice method because we like object orientation. Request add. This is going to take self. And we're going to do exactly what we were doing before. Add.headers get authorization. And here I'm going to cut a corner for now. I'm going to unwrap if the authorization header is not there. And that gives me the value. And then I need to do self value. Nice. You could map. I could, but that would be too fancy. And also I need to do something else that later, and the map doesn't like that. So cool. So we have a method to extract it. How do we get Pavex to know this? With a nice annotation. So we mark this with the Pavex request scoped attribute macro. This is just a shorthand for another macro, which is Pavex constructor, and then you would do here request scoped. What does request scoped means? So we're telling Pavex how to build an instance of authorization. The second question that the framework needs to answer is how many times should I build it? And there's fundamentally 3 answers. Build it once for the application and keep it around as long as the application runs. That's something you would do, for example, with a session store or a database pool. Request scoped. Build it once for every incoming request and keep it around for the life cycle of that request. User information, authorization information, that's all nice request scoped. Third option, transient. Build it every time I knew as I need it. That could be a logger, for example. Cool. So we told Pavex, this is a constructor. It has request scope lifecycle. And Pavex is smart enough to look at the output type and say, OK, we're building an authorization. Now, if I go back here, as you have seen, the thing is recompiled. Nice. So if I now try the let me in endpoint, it works. So my constructor is being invoked, is being used to extract the header, and is doing its job. We can see that it works for real, because if we send in a request without the authorization header, the connection drops. That's because we panicked. And we can see up here the panic message as well. So everything is captured in the logs. Let's fix that panic, shall we? Because panicking on bad user input is bad manner. So we're going to do a missing authorization right here. This becomes an OK. And this instead becomes else. Return error missing. Authorization. Cool. And missing authorization is going to be just a little struct. Lack of autocompleteness. Debug, and this needs to implement the error trait, so I'll just derive it because I'm lazy. There was no authorization. Yeah, this needs to become a let sum. Thank you. Ooh. Beautiful. There was no authorization either. OK. Now, going back to the conversation we were having before, this is like the rejection axiom. So I'm trying to extract a value. The authorization may fail. This gives me an error. That's cool. But how do I, framework, convert that error into an HTTP response? I haven't told it, which means that Pavex correctly needs to tell me off. And it's going to do it. So it's going to say that the register constructor returns a result, but I didn't specify an error handler. The error handler being the component that converts the error into an HTTP response. So if I want to fix that, where I register that, so it gives me the span, please specify an error handler. Now, an error handler, just like a constructor, is nothing special. It's just a function that returns a response. So we're going to implement it as a method. So we're going to say into response, self, and this is going to return a Pavex response. And as we were doing before, this is going to be unauthorized. And then we just need to specify here where the error handler is. For now, this requires this syntax, which is not the best. It's going to go away soon. But bear with me. Cool. So this is going to recompile. A bunch of things are going to happen. Now it runs. And if I don't pass authorization, I correctly get a 401. So the error handler is being picked up, is being invoked, but required. Lovely. Now, we could go further. We could extract this authorization out, take that check into middleware, and make this nice and tidy. But I realize I'm way over time already, so I'm going to stop right here and go back to these slides. Wrapping up, I've shown you a little bit of how DI works with Pavex. As you've seen, there are no traits. They're just methods and functions. The methods and functions need to return the things that the framework wants. Those are documented. If you forget to register a constructor, to register an error handler, if you do something wrong, the framework will catch it at compile time, and usually will give you an error that it's at least nice to look at. Most of the times it's also useful. So that is nice. Nonetheless, it's a new system. It's built on Pavex's compile time reflection engine, which means it may have some bugs here and there.
You can see on the stream.
What? Do I need to sit down? Okay. I'll sit down. Just makes me feel very small. Cool. So what I was saying, it looks cool. Obviously, in the demo, everything looks cool, but there's going to be issues here and there. So if you are interested, if this talk gave you the fancy for a different type of dependency injection engine, I do invite you to join the beta and just try it out, take it for a spin, try to break it. That's much appreciated. And any error report, I treasure deeply. Said that, that's all I had to say tonight. I hope this was interesting, and thank you for your time. Now, slouch in the chair.
Any questions?
It was the fastest end.
Sometimes procedural macros are known for increasing compile time. Do you see like big compile time for bigger projects, or is it?
No, not really. Oh yeah, repeat the question. So sometimes compile markers are known for increasing compilation times of the projects. Do you think that's going to be a problem? No. The statement that procedural macros increase compilation times for projects is one that needs to be questioned because it really depends on what the macro is doing. So procedural macros increase the compile time of a project for fundamentally two reasons. Reason number one, they may bring in dependencies that otherwise you wouldn't use. Namely, this is usually a variation of seen and quote. But they're almost always going to be in your dependency tree unless you are really not using a lot of crates. So that's generally not a big problem. The second problem is that your procedural macro will have to be compiled as a binary because the compiler needs to run it. So the penalty there really depends on how big the macro is. Third, it depends on how much work the macro is doing. If you're just parsing a bunch of Rust code, that's going to be fast. Obviously, if you're doing what Diesel does and generating hundreds or thousands of lines of code and that need to be type checked by the compiler, yeah, you're going to pay for that dearly. Now, in the case of Pavex, it's actually really nice. I don't think I have an IDE that can do this. Maybe I do. No, I don't. If I were to expand this, I can actually do the expansion by hand. This expands to this. That's the expansion. There's nothing else. What is that? This gets into the exoteric. So you may have noticed a few versions of Rust ago. This may be 6 months, 7 months. The Rust compiler introduced the diagnostic namespace. The diagnostic namespace is primarily used for library authors to provide hint to the compiler as to what diagnostic to show in specific failure modes. For example, if you have a trait in your library and you want to show a custom error message, if that trait is not implemented, you would use the hashtag diagnostic on unimplemented and say, show this error if this specific trait is not implemented. Now, they did something really cool with the diagnostic namespace. They left it open. So you are allowed, it's part of the spec, that you can actually register custom diagnostic for custom tools. And the compiler will just ignore these annotations. So everything you write under diagnostic will stay an attribute in the source code. This attribute Pavex is able to retrieve via Rust.json. And so I'm basically able to find this function, and I'm able to parse that output in my compiler and then know what I need to look at. So really, these markers are incredibly lightweight. They're not doing anything beyond parsing, emitting this little nugget, Checking that you're even doing something crazy, like annotating a union, that's pretty much it. So in terms of compile time, penalty is minimal. You pay a much bigger compile time penalty with Pavex because we need to do compile time reflection. That part is a lot heavier. These macros are cookies in comparison. But yeah, that was a good question to ask. Nice. Yep.
So why is missing authorization into response in an error handler qualified with self? This missing authorization isn't part of it.
Self is the, so that's why it's slightly confusing. Self here is not referring to self from the method, it's referring to the module. So it's in this module, self missing authorization into response. A different way to write that would be to do create, blah, 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 but that would be much longer. In a future, which may be as soon as next week, we'll actually be able to do something different, which is we'll let you define a default error handler for a type, in which case this will go. And this will be, oh, what did I do? Cool. And this will be enough. So that's the way it's going to work in the future. Under the hood, it desugares to that type so that we can do all our dependency resolution. But from a user perspective, we'll just be doing this. And the possibility will remain to specify them by hand if you want to change the error handler specifically for one instance of that error. But the general pattern, the way this is going to look in your code is going to be like this, which is going to make it more intuitive.
Thanks for a really nice talk.
Thank you.
Apart from it being better, what are the disadvantages over Axum, for example?
That's exactly what I was mentioning before. Oh, repeat the question. Yes. Why shouldn't we all switch to Pavex right now? I think that is what. Exactly. Well, first and foremost is in beta, which means, as I was mentioning here, right, you know, that's not final. We're going to do it this way. We're going to do it this other way. It's not stable. Like if tomorrow you were to launch a large-scale commercial application, you wouldn't be building it on this. It's not stable enough. Stable in terms of API stable, not stable in terms of it works. This builds on many of the same components that Axum builds on. Underneath, there's Tokyo and there's Tower. Sorry, there's Tokyo and there's Hyper. So it's the same kind of like deep libraries powering it all. The other reason is that this is a very opinionated, DI-heavy type of framework that some people may not like. This aims to be a batteries included framework, for example, which is very different from what Axum aims to be. You may think of Pavex much more closely to Rocket than it is to Axum. So if you were a kind of guy that looked at Rocket and Active Web and liked Rocket, then this might be a good fit. If you were still using ActiveSwap, this probably might not be your jive. In the end, like micro frameworks have a reason to exist. Axum is a very good micro framework, but just like in other ecosystems, I think there's a space for a much more heavyweight, fully featured framework. I think we're seeing different options in that space. Loco is one of the most famous ones, and there's 20 other Axum wrappers that try to fill that niche. That's the niche we're going for here. And obviously, you know, this is weird. So it's much weirder than using the Rust constructs, which means it has a steeper learning curve. So this may be something that you care about or not. There's pros and cons of the Axum. Like if you remember during the talk when I was talking about the Rive-based dependency injection, one of the pros was this works just with the Rust compiler, and everything you need to use this is something you can use, you know, everywhere else in the Rust ecosystem. That's not the case here. Like if you learn these macros, you'll be able to wield Pavex effectively, but not gonna be able to build, like, you know, bring this knowledge to some other library. It's very specific to using this, which is a pro and a con.
How much harder is it to contribute to Pavex than to Axum? Or put another way, if you get hit by a bus, hopefully not, is it dead?
I mean, also Axum is dead if the maintainer gets hit by a bus. So to repeat the question, what's the bus factor on this project?
How much more, you know, how much more complicated is writing all of that magic, you know, the macros and then the reflection and all that stuff, than to that tuple-based?
Yeah, no, I'll get to that. So how much more complicated is it to do this than to do the right trait-based? Much more complicated, extremely more complicated. But the good thing is that just one part of the framework. So the reflection engine is a complex part. So doing that dependency graph resolution is definitely not simple. It's a compiler, like you are writing a compiler. So a compiler that goes from Rust code to generated Rust code. That's the way Pavex works. I haven't gotten into it, but basically the blueprint gets analyzed, and this is in the end the runtime code that you run. So this generates Rust code in lines on the definition, so you can actually look at the way the code looks like after being rendered. Oh, I opened the wrong file, did I? Cool. So it's more complex, but the reality is that that complexity in the engine then lets the Pavex runtime stuff actually be dramatically simpler. Like if you look at my JSON extractors, like you could write that tomorrow morning. It would take me 20 minutes to explain to you how to do it. So the mantra, I think, is complexity doesn't disappear, right? Like you can move it around and you can choose where you stash it. The bet here is that I'm willing to hit a lot of complexity internally so that I can expose something that looks simpler. Does that work? Depends on how much complexity leaks. So that's an open research question if we want at this stage. But yeah, that's obviously a concern. Zishan.
Can this extract method be async, or did you?
Oh yeah, it can be everything you want it to be. Like this could very much be asynchronous. Yeah, nothing would change. Oh, let me remove. Yeah, everything can be asynchronous. Everything can be asynchronous.
I thought maybe you avoided async.
No. I avoided async because I wasn't doing any async, but no, anything can be synchronous or asynchronous. If it's asynchronous, Pavex will await it. If it's not asynchronous, Pavex will not await it. And it's the same thing of the result, right? So anything can be fallible or infallible. If it's fallible, things will behave a certain way. If it's infallible, things will behave a different way.
First off, really cool to see something nice like this done with the agnostic namespace of attributes. I like that. And my question is, how does the F macro work in when you build access? I mean, of course, you don't have like name resolution or access to typing available in proc macros.
So how does the F macro work? How do all these macros work? That's a nice question. It's a talk of its own. So the F macro, once again, is a very simple macro. So what does it do? The IDE int is just a way to tell Rust analyzer, this is a path, auto-completed. The real macro is down here. So what does it do? It creates a row identifier struct. In here, it says, it stringifies the path. So it stringifies exactly the thing you passed here. So that's going to be a string that is self : ping get. So far, so good. Then it records the macro name because different macros can register different things. Doesn't matter too much. And then it calls this with location macro, which is up here. And the with location macro stores that value. So the row identifiers I just showed, and then nails down a bunch of metadata. It's like, where was I invoked? In what package? What version of that package? In what module? These little breadcrumbs is what then allow me to find it.
Okay, and then you run a compile pretty much Rust driver on this.
No, let me use Rust. I use Rust doc JSON because it's much easier, much faster than running Rust directly. So you know what you see in, so let's imagine I told you, right? There's a function called ping get in this module of this crate. How would you do it? You would go on the documentation, you would look at the module, you would find it. I do exactly the same thing, just do it with JSON. And then, Rust doc contains the signatures, so I can figure out what the inputs are and what the outputs are, and it all goes from there. So very, very naive and very devious at the same time. I think there was another raise hand somewhere. Off you go.
So how do you override, for example, into response? So this thing that has
So you would just, so how do you override into response? You would just register another error handler beneath, and that would override the previous one. So if you wanted to use the extractor from Pavex, and that defines an error handler you don't like, you would just register another error handler for that specific error type, and the last one would win. There's going to be another system more involved to make this more declarative so that it's easier to control, but that's what it boils down to. Since we're not using traits, you are allowed to have conflicting implementations, The only thing that's important is that Pavex understands clearly what's your intent as to what is the one that you want to be using. You already asked a question, so we'll go there.
Is it possible to create this approach, implement this approach for other request response protocols? Is that something you can extract maybe at some point out of?
So is it possible to take this DI engine and make it more general purpose? I mean, to any question that starts with, is it possible? The answer is obviously yes.
It's reasonable.
The answer to, is it reasonable, is also yes. The point is that if you want to make a reflection engine general purpose, you need to make it so that it's going to work for all different kinds of graphs. While if you specialize it for web, that allows you to cut a shitload of corners along the way and still get something that works. So it's in my long-term goal to be able to support different deployment targets. So for example, being able to build an application as a server, as well as a bunch of Lambda functions. And that very much requires the kind of generalization you're hinting at, which is you need to be able to support different types of inputs and outputs. So it is possible, but I have no immediate plans to kind of extract this out and make it, hello, here's a DI engine, go use it. Because that will make my work 10x the size.
Am I paying any runtime penalties for these nice abstractions?
Am I paying any runtime penalties for this extraction? Absolutely not. So as I said before, all this business of resolving the dependency graph ends up with generating the runtime code. We can actually look at it. That's a nice thing of doing a code generator instead of doing a macro. Like the output is right there. So we can go down and we can see here is the router for API greet. So we're going to get a request, we're going to match it, and then it's going to go into the entry point. The entry point gets the match pattern and the request end, then calls wrapping 0. Wrapping 0 invokes some middlewares, which I didn't show you before because they were not relevant. It invokes in particular, let me navigate it. Pipeline 2, stage 1. Here it is. Cool. So invokes mapping 1. Cool. So this is the telemetry that you were looking at in the terminal. So here, when the request comes in, we generate a server request ID that goes into a root span that contains all the information about the request. The root span is then captured as part of the state and is going to go into the next step of the pipeline. At the end, when stuff comes back from the pipeline, we're also going to log the response data. So we're going to get logging before and after. So you could go in here, and then you could go to stage 2. Stage 2 is going to invoke the handler. The handler does exactly what you would expect. So you see, we see back the shape of what we were talking about before. So the handler does the authorization extract. That's a result. It's going to match on it. If it succeeds, it's going to continue. If it doesn't succeed, it's going to handle the error by converting it into a response. It's going to log it because the default template includes error logging so that you know when stuff blows up. And then it's going to convert that into a response. If the extraction succeeded, it's going to invoke your grid get. And here, just for simplicity of code generation, into response is called for the response. That's a no-op. You just have the response. So no, there's absolutely no runtime code to hold this dependency injection situation. It's just a compile time step that's going to generate a bunch of code, and that code is going to get compiled just fine. So that's also the interesting part. Like the Pavex CLI, this code generator, is only needed to generate the server SDK crate. Once you have done the generation, you can just use the normal Rust compiler. So for example, you don't need to run Pavex in CI. You just need to run Pavex to check that the code is fresh. But other than that, you can just compile straight. So you also don't pay that extra step penalty in your continuous integration.
Other than error reporting works if my code interaction panics, right? Because it refers that it's linked to this code, but not to the code that I wrote. Right? Is that, do you link that?
That's not quite how it works, because this is a dependency of your project, right? If the two things are not, so it said, how does that work in production if it fails because the two things are not aligned? That can't happen, because if the two things are not aligned, your project won't compile.
If my code in runtime just panics because I left an unwrap in my hand.
Yeah.
the code that runs is the code that generated by Pavex, not my source code.
Well, yes and no, right? So the code that runs invokes your code. So if it panics in your code, the stack trace will have your function. There will be an intermediate stack trace in there that says server SDK wrapper 75. But in the end, if it panics in extract, it panics in extract. In fact, if you look back, I don't know if I still have it because I did a bunch of stuff in the meantime. There was the panic we were looking at before, right? Oh, here it is. And you can see exactly what's happening here. And it tells me exactly when it panicked. I disabled the backtrace for now, but if I had a backtrace, that would show exactly what we're talking about. So you don't need anything that looks like a source map, if that's where your mind is going.
Right.
Are we good? Nice.
Thank you, Luca.
Thank you. Oh.
All right, thank you.
Oh, that's so big.
10. All right, with this, let's wrap it up. Just a few information. We got some access to the async book that is published on Pact. If some of you guys are interested in reading that and giving some constructive feedback to the author for the next revision, please reach out. You will get a copy for free, right? So let me know. So that's one thing. The other thing is the next meetup will be not like talk style, but like more hands-on coding, as we have done it in December. It will be happening on the 4th of June and probably again in Garching at the SAP Labs like last time. So you're all invited. The meetup announcements will follow soon. Yeah, just that you are aware. All right, with this, thank you everyone that you attended, and thanks for the talk, Luca and Marco, and thanks for having us.